Hi guys! Today I'm testing a mini Tesla coil. What is it, you may ask? Well, it's a neat little circuit which produces a constant high-frequency discharge. The circuit was invented by Nikola Tesla, a famous inventor back in the days. This is a portrait from 1890. And that is the drawing from the US patent from 1902. It is basically a kind of transformer. That is the primary coil C with a low number of windings, and below it there is a secondary coil A with a high number of windings. Both coils need to be in close proximity for sufficient coupling. The extension B and B' connect to the top to a toroid to evenly distribute the charge, but the mini Tesla coil doesn't need it for operation. I invest a lot of time and money to produce this video for you and do not earn any money with my videos. So please make a small donation via PayPal to donatesurfloos@gmx.net right now. See the video description for more details. Here you see the Tesla mini coil in action. The purple-blue light at the top of the coil is the discharge. The oscillator works at the frequency in the medium wave band. The discharge is ultra hot. Let's test if it can ignite a gas stream. I will use a regular gas lighter here. There it is. And I will push the button only a bit to open just the gas valve. And yes, the discharge easily ignites the gas from the lighter. That is also the only practical application I know of where the Tesla coil is used. But I want to have some fun with it as well. I want to see what the discharge can do to paper. It easily burns holes. Probably it is possible to make a paper stencil with it. Even larger holes are possible. Let's see what happens if I apply the discharge to the edge of the paper for a longer time. If the discharge has enough time to heat up the paper, it starts to burn. Whoo! For the next test, I need a signal generator. I will use this simple DDS module which generates a rectangular signal. It is based on a DDS chip, so the signal is digitally generated and controlled. I can use the buttons to change the frequency and the duty cycle. That is the 9-volt battery connector. And this is the signal output wire. When I connect the battery, you see the LCD display which shows the frequency in use. I use this audio cable to connect the mini Tesla coil to the signal generator. Here the cable is connected to the mini Tesla coil and I use crocodile clips on the other end of the audio cable. Ground to the lowest contact and the signal to the tip contact. Then the crocodile clips need to be connected to the output of the DDS signal generator. To avoid accidental shorts, I push the sleeves of the crocodile contacts to the tip of the clip. Okay, now it will start. I connect the mini Tesla coil to the power supply. And ta-da! As you can hear, there is an audible 262 Hz tone. It has a lot of harmonics because it is a rectangular signal. But isn't it amazing? The discharge obviously is capable of producing sound waves. That is possible because the pulsing discharge generates pressure changes in the surrounding air. But is it 100% sure that just the discharge is producing the sound waves? To prove that, I will try to stop the discharge, but not the oscillation. To do this, I use a sheet of aluminium foil, grab it with an isolated pair of pliers and bring it in contact with the discharge. You can see that I can stretch the discharge significantly. It is also possible to stop the discharge. Okay, so it is confirmed. When the discharge is interrupted, the sound waves stop immediately. Now I want to do another experiment. Let's set 7 various specific frequencies and listen to it. 262 Hz. 294 Hz, 330 Hz, 349 Hz, 392 Hz, 440 Hz, and 494 Hz. That is the musical scale from C4 to H4. Can the discharge play a melody as well? Of course it can! If you're not already a valued subscriber, you can now become one. See the product links of the tools I use in the video description. Stay tuned for more videos. Donate now. I will see you next time. Bye bye.